Hi, we're Team HAWKS, and in this video we'd like to show you what we've been doing in our final year project, an assessment of harmonic currents in future distribution networks. In this project, we've been assessing the impact of harmonic signals in a distribution network and whether the introduction of electric vehicles could introduce new problems for both customers and network operators alike. Harmonics refer to any additional signal that has a frequency that is an integer multiple of the fundamental frequency. In a distribution network, current harmonics are drawn by nonlinear loads, devices that convert the voltage signal into another form, through a rectifier, ADC, or some other form of power electronics. The modern home already includes many electronic devices that all behave as nonlinear loads, but the introduction of larger loads, such as electric vehicles, could rapidly increase the significance of current harmonics. From the start, it was clear that this project was easiest to tackle from two sides. Osman and Ewan would focus on measuring common household electronics to obtain harmonic profiles of many different devices, while Daniel, Brian and Paul would build a software model of a distribution network. Once the model was complete, the data from the measured devices could be input to simulate the behavior of harmonics in the network. Ewan and Osman began by designing a splitter box that would allow the measurement of household devices without physically splitting the power cables into their live, neutral and earth wires. This box contained a current clamp for current measurement and probe connections for measuring voltage. During testing, an Amatec power and quality recorder was connected to these probes, and the harmonic profiles of each device were viewed and stored on the laboratory computer. The measurement team also made a trip to Scottish Power's electric vehicle fleet in Edinburgh, where a Peugeot TP was tested extensively, and later in the year we also gained access to a Nissan Leaf through the Leap Car Club. Meanwhile, the modelling team were hard at work on designing and implementing a distribution network model. A modular design seemed like the easiest to use and understand. A number of different houses could be created by bringing together several of the devices measured by Ewan and Osman, and then different combinations of these houses could be used to model several types of spur. Moving one level up, a number of different feeders could also be defined as different combinations of spurs. 4 of these feeders are then attached to a low voltage transformer, and 8 of these transformers are attached along an 11 kV feeder. 3 of the 11 kV feeders are attached to a 33 to 11 kV transformer to complete the model. Starting from the houses up, currents can be added together at each junction to find the currents in each stage of the model. The voltage drops in each line can also be calculated from the current and line impedance. Once the total current at the 33 to 11 kV transformer has been found, the voltage is set to a nominal value, and the potential at each junction can be found by subtracting the voltage drops that were calculated earlier. This two-step process provides us with voltage and current values for every level of the model. After analysing the results of our simulations, we found that current harmonics had made a significant impact on areas of the network. Currents through the neutral cable were increased dramatically due to the presence of tripling harmonics, and significant temperature rise could be seen in the transformer windings. When a high number of electric vehicles were introduced to the network, the low voltage feeder cables were at risk of overloading. We also found that these effects were much worse when using the TP harmonic profile in place of the Nissan Leaf. We proposed that one method of reducing harmonics in a future distribution network would be to enforce stricter standards on electric vehicle manufacturers. Thank you for watching our video, and we hope you enjoy your time here at the trade show.